So when it comes to multiplying whole numbers and integers, what we're primarily doing is adding numbers in groups. So when I have 3 times 2, I'm going to have a group of 3 like this. And then I have 2 groups of them, so I'm going to add another group. And then I count up all the dots that I have. I have 6. So my final answer is 6. And another example of this would be 4 times 3. So I have 4 groups, or 3 groups of 4. 1, 2, 3, 4. Then I'm going to make 2 more groups of this. 3, 4, 1, 2, 3, 4. And if you add them all up, your answer is going to be 12. And you can do this with either the first number or the second number. It doesn't matter. Where you can have this number be the group or 2 be the group, and it works either way. As if I were to do 3 groups of 2, I have, here's my first group of 2, and then I'm going to add 2 more to get 3. Like this. So this works when you're dealing with 2 positive numbers. However, this is not always the case, as you could have 2 negative numbers. And when we have a negative number, or 2 negative numbers, so I'm going to do an example of minus 3 times 2. So what happens when we have a negative number and we multiply a positive number with it is it will become negative. So instead of me using the blue dots, I'm going to use the red dots to signify that they're negative. And the same rules apply where I'll have a group of 3, and then I have 2 groups of 3, like this. So I have 6. So my answer is 6, but since I had this negative, I had to put the negative sign on the 6. And this will always hold true when you're multiplying a negative number and a positive number. And if you were to have 2 negative numbers, let's say you had minus 3 times minus 3, what happens is these actually cancel out. So this becomes 3 times 3. And then you go through using the same procedure. Where I have a group of 3, and then I have 3 groups of them. So I'm going to add 2 more. So now I have 3 groups of 3. This is equal to 9. And this will always hold true, that when you multiply a negative number to a positive number, you get a negative number, and when you multiply 2 negative numbers together, you get a positive number, and then when you multiply 2 positive numbers, you get a positive number. Now, what if we were to multiply 2 numbers, let's say 15 times 20, and you can either use the dot or the x for multiply, they both work. So this would take a long time for me to count out either 20 dots or 15 dots and then group them up respectively. So what I'm actually going to do is there is a better method to do this, and this is called long multiplication. And what I'm going to do is I'm going to just write 15 times 20 like this, and then I'm going to solve it. So the way you do this is you're going to look at the bottom row, and then you're going to go number by number. So what you're going to do is you're going to look at the 0 first, and then you're going to multiply the 0 by 5, and then the 0 by 1. So when you do it, you're going to get 0 and 0. And then you're going to go on to the next number, which is 2. And then you're going to multiply the 2 by 5 and the 2 by 1. And what you're going to do is you're going to go to the next line. However, you're not going to start right here. You're actually going to go 1 number over, and you're going to start right here. So 2 times 5 is going to be 10. I'm going to do a 0, and then I'll place a little 1 up here, because that's what I'm adding into the next row. Then I'm going to do 2 times 1, which is going to be 2, 1, and then these numbers will add. So this is going to be 3. this is still going to be 0, and this 0 is brought down to get 0. And my final answer is going to be 300. So I'm going to quickly erase everything and do another example. So I'm going to choose the number 17 times 48. So I'm going to start with the first number on the bottom, the 8, multiply it to the 7 and the 1. When I multiply 8 times 7, that's going to be 56. So I'm going to write a 6. And then the 5 is carried over up here, up top. And then 8 times 1 is going to be 8. And then remember, these numbers add back up. So my final answer for my first row is going to be 136, as 5 plus 8 is 13. And then there's a little 1 up here because it's carrying over to get 136. And then I'm going to go on to the 4 for 48. So multiply the 7 and the 1, making sure that I don't start right here. I move 1 over to start in the tens place. So 4 times 7 is going to be 28. So I'm going to do 8. And then I'm place the 2 up here because it's carrying over. And then 4 times 1 is going to be 4, like this. So then you bring this down, 6. You add these two numbers up. So 3 plus 8 is going to be 11. So I get a 1. And then now I place that extra 1 just up here. I don't really have another place to put it. And then 2 plus 1 plus 1 plus 4 is going to be 8. So my final answer is going to be 816. And then this last example, I'm going to choose the number 13 times 99. So I'm first going to start with the 9 on the right, multiply it by 3 and 1. So 3 times 9 is going to be 27, right? Right, 7, put 2 up here. And then 9 times 1 is going to be 9, like this. Add them together. So this is going to be 7, 1, 1, like this. So now it's time to do the next 9. Multiply it again by 3 and 1. And then I move over 1. So I'm going to place a 0 when I move over just to help visualize it, that I'm moving over. So 9 times 3 is going to be 7. And then I add the 2 up here because it's the carryover. And then 9 times 1 is going to be 9, like this. We add all them up. So I get 7, 8, 2 plus 1 plus 9 is going to be 12. So I'm going to write the 2 and then the 1. And then this is my final answer, 1,287. And that'll be it for my showing of long multiplication. And there is one more process to multiplying whole integer numbers, and that is going to be exponents, which was covered briefly in an earlier video. So if you remember, exponents are 2 to the power of a number. I'm just going to call it x, and this can be any number. So let's say I have 2 to the power of 3. What that's going to be 2 times 2 times 2. So this number 3, or x, is going to be how many times you multiply that number. So if I had 3 to the power of 4, that's going to be equal to 3 times 3 times 3 times 3. And this is equal to 81. And this will hold true for any number where we have this being the base, this being the exponent. And a quick tip for multiplying multiple numbers at once like this. So there's 2 ways you can do it. You can either multiply each number. So I do 3 times 3, which is 9, and then 9 times 3, which is 27, and 27 times 3, which is 81. Or the other way to do it is by doing 3 times 3, which is 9, and then doing the other 3 times 3 over here, which is also 9. And then you can multiply these two numbers to get 81. All right, so doing division, there are two methods. There is the long division method, and then there is the grouping method. So I'm going to go over the grouping method first. So the grouping method involves using circles to group them. So as an example, if I'm doing 6 divided by 3, I'm going to draw 6 circles. And when you're doing a number divided by a number, it's always going to be this number of how many circles you draw. And then this one will be how many groups you make. So doing 6 divided by 3, I'm making groups of 3. So I have 2 groups of 3 that are possible, and then my answer is going to be 2 because I can divide 6 into 2 groups of 3. And another quick example of this is doing 6 divided by 2. So I'm going to quickly do that. And then now I'm dividing them into groups of 2, which I can do like this. So that means 6 divided by 2 is equal to 3. And this will work in most cases. However, let's say you have a case like 9 divided by 2. So you have 9 circles, but you're dividing them in groups of 2. So I have 1, 2, 3, and 4. However, I have 1 left out. So what your answer is going to be is it's going to be 4 and decimal because the number is less than 1. And then you're going to put however many you have left. So I have 1 left. And then how big the groups are. So it's going to be 1 over 2. And 1 over 2 is equal to 0.5 or 1/2. So my answer is going to be 4.5 because of that. I'll do one more quick example of this. I'm going to do 10 divided by, I'll do 10 divided by 3. So I'm going to draw 10 circles. And then I'm going to make them in groups of 3. However, so I have my 3 groups of 3. And then I have 1 left over. Right over here. So I'm going to write my answer. So I'll get 3 and then period, because the last of it is going to be less than 1. And then I'm going to put however many I have left over, which is just 1. And then however big the groups are, which they're groups of 3. And if you to put this in a calculator, you would get 0.333, and then it keeps on going on. And when a number keeps on going on forever, you put a bar over the last number in the decimal. And I'm going to write out 3.33 and then the little bar to show that it keeps on going on forever. However, doing division can also be done with long division, which will be more useful when you get bigger and bigger numbers, as it won't take as long to draw that many circles and less likely to make mistakes. So the way we do this is I'm going to choose a bigger number, do 125, and I'm going to divide this by 5, which is a different notation as this, where the number on the left will go underneath and the number on the right will go outside. So when doing this, you're going to work from the left to the right. So I'm going to look at 1, and I can't divide 1 into 5. So I'm going to then add the next place, which will be 12. So I can divide 12 into 5, 12 into 5, and that is 2 times 5 equals to 10. So I can write a 2 up here, and then you're gonna do a negative out here, and then put what number that you're using. So I get 2 times 5 equals 10. So I do 12 minus 10 now, which is going to be 2. And then you bring down the 5, or you bring down the next place. So now I have 25, and 25 can be divided by 5, and that gives us 5. And then 25 is our final answer. So long division requires a lot of looking at different places, different decimal places, and knowing your multiples of your numbers. So I'm going to do another quick example. This time I'm going to do 33 divided by 2. So I'm going to look at the first digit, which will be 3, and then I can do 3 divided by 2, which will be 1. Do the minus. 2 times 1 is 2. And then what am I going to get? I am going to get 1, and then you bring the 3 down, so I get 3. So now 13 can be divided by 2, or it can be partially divided by 2. When I do 2 times 6, that's going to be 12. So I can write a 6 up here, and then 13 minus 12. Then I'm going to get a 1. And then what you can do is you can stop right here and say your answer is going to be 16 remainder 1, like this. Or the next thing you're going to do is you're going to add a decimal place and then add a 0. And then you bring that 0 down, like this, like what you've been doing before. And then 2 divided by 10 is possible. That's going to be 5. Make sure to put the decimal in the answer, like this, and then that would be it. And then your final answer should be 16.5. Another way is if you're to do something like the grouping method, where you get 16 remainder 1, you can still do remainder 1 would be 1 over 2. And then you would. All right, so I'm going to go over 2 more examples of this. So the first example is going to be 400 divided by 10. And since 10 is 2 digits, I'm going to look at the first 2 digits of 400, which is going to be 40. And 10 times 4 is 40. So I'm going to do 4, and then subtract the 40 from 10 times 40 is 0. And then bring this 0 down. And then 0 times 10 is 0. To keep 0. And then my answer will be 40. So when you have like an edge case like this where you have 2 zeros brought down, or you have a 0 and then a 0 is brought down, it's going to be 0, and then you subtract a 0 to get to the next place or digit. And then the last example is going to be 101 divided by 10. So since 10 is 2 digits, I'm going to look at the first 2 digits of the 101, which is 10. So I can put a 1 right here, since we're going to do 10 minus 10, or 10 divided by 10. Right? And then that's going to be 0, and bring the 1 down. So I cannot divide 10 into 1 at all, so I'm just going to put a 0 to do 1 minus 0 to get 1. And then before, I'm going to do a decimal and then place a 0. Do the same thing right here, so I can bring this 10 down. So now I have a 10, which I can, did not mean to do this, which I can then do 10 minus 10 to get 0 to finish it off. So my answer would be 10.1, or if you were to stop at this step, since you can't divide any further, you'd get 10 remainder 1, and then you can do 10 point, and then you have 1 over 10. So you go to 0.1 to add that 0.1 on the end. All right, well, that's it for this video. If you liked it, please leave any some more